My name is Eileen Goldberg with LCI, and I'll be your moderator this morning for our webinar Integrating BIM and Lean for Project Delivery, Construction of a Major Hospital in Jordan, put on by CCT International by Zuhair Haddad, and we'd like to thank you guys for being on our webinar. There's a couple of housekeeping items that I'd like to go over before we actually really get started. The first is that this webinar is being recorded, and the webinar and a copy of our slide deck will be available on our website at lcicongress.org under the exhibitor section within the next couple of days. So please keep an eye out for that. I also wanted to share with you there's a long box on the right-hand side of your screen. There's a red arrow on that box on the left-hand side that is the minimization and maximization arrow to allow you to view the presentation more closely. Also within that long box is a questions box. Please be sure to write any questions that you have during the presentation in that box. They will be answered hopefully at the end of the presentation. This is a rather long presentation, so we're going to be moving rather quickly. Hopefully we will have time for your questions and answers. We might not, so Mr. Haddad will be able to get back with you after the presentation. So please be sure to put any questions that you have in that questions box. It is very important to do so because we might not have time for Q&A. I also wanted to let you know that we will be doing a plus delta at the end and during the presentation as well. So any feedback that you have would be fantastic. For those of you that are not familiar with the term, plus are things you enjoyed about the presentation, you liked, you thought we explained well, and deltas are wishes, things you wish we would have done, things you thought we could have done better, things you wish we wouldn't have done. We appreciate your feedback so we can make our webinars more applicable to things you'd like to learn, and I know that CCT International will appreciate your feedback as well. So just to go over a couple things again, the webinar is being recorded. It will be available on our Congress website at lcicongress.org. The red minimization and maximization arrow on the long box on the right-hand side. Please do be sure to put your questions in the questions box as we go through, as this is a longer presentation and we might not have time for them at the end. And again, please put your plus deltas in as we go through the presentation as well. So without further ado, I'm going to turn it over to Mr. Haddad. Thank you so much, sir.
Thank you. My name is Zuhair Haddad. I'm CIO of CCC, which is a major construction company. CCT is the software arm that we use to develop software for construction management. So who we are? We are on the top 20, we are the 22nd on the Engineering News Record list of international contractors. We have high safety and environmental consciousness. We operate in all continents, but mainly in the Middle East. We have around 6 billion in revenues. We have around 150,000 employees, and our construction fleet of equipment, construction equipment, is a replacement value of 1 billion. We work with most of the major clients in the world. We do heavy civil, which is like dams and ports and airports, process plants, refineries, etc. Oil and gas facilities to process oil and gas, infrastructure and networks such as water systems, sewage systems, etc., roads and bridges, buildings and pipelines. And in this presentation, I'm going to talk about buildings. The project is a hospital in Jordan. It includes building the structure itself, architectural finishes and MEP packages, mechanical, electrical, and equipment. The project duration was 730 days, commencing 1st of April 2014. The current workforce, that was last year, 850 persons and more than 40 subcontractors, so the coordination was a challenge. And most of it is in the architectural and MEP packages. The hospital consists of 182 rooms and is comprised of 2 towers, 10 floors and 12 floors each, and above ground sharing the ground floor and 3 basements. The total area is 84,360 square meters, which is around 840,000 square foot. So the challenge is this project was a small project, relative but highly complex. Many systems, multiple room configuration, you have patient rooms, you have x-ray rooms, you have so many types of rooms, a lot of specialties and subcontract. And we wanted to use CCC project control, and we decided to concentrate on the room finishes because that's the most complex part of the structure wasn't a problem. The problem was in the finishing the project on time, the fast track finishing and handover. And if you know something about hospitals, the hospital will only order the major equipment very late in the project duration because they want to get the latest models. And so the coordination with the subcontractors becomes hard. So our project control strategy, we are a lean-oriented company, so we really use reliant pull-driven technique to optimize supply chain rather than, and we want to prevent sub-optimization. So our system looks to assure availability of resources before start of an activity, emphasize productivity through the full work chain versus individual activities, which means preventing sub-optimization. We want people to do exactly what we need so that the next step can happen. We don't want them to do the easy work first and then leave the hard stuff until the end. We believe in partnering, so we work with our subcontractors so that we all can achieve our targets. We do this through a standardized project work breakdown structure, which is 7 levels. I'll talk about it later. And we start with the construction and handover activities, and we go back and try to get the engineering and the procurement to satisfy this requirement. We emphasize 3D built model with W, so we use 4D and 5D. The model itself reflects the work breakdown structure so that it's easy to subdivide the sections and be able to give people work packages. We always work with our partners, and especially we emphasize the electronic data interface so that we get the data as we want it and the 3D model, and we do clash checking, and we are able to manage the construction using models supplied by our subcontractors. 3-month look ahead schedule, material for the plan to make sure that all the required resources are available for our project, and 3-week look ahead schedule is to plan the work of our subcontractors and our crews to make sure that we don't have conflicts. So this is basically the workflow we go through. I will detail it as we go around. The first thing is we said WBS, which is how we divide the project. And it's very important for us because we use it also to name the objects that we want to use. So basically we divide the project into major areas, and then within that major area, level 3 is sub-areas. Level 4 is what I call a fragnet, and the fragnet is a phase plus a method of construction. So a phase is like structural, finishing, handover, and it may be like, for example, the toilet rooms will have a different fragnet because the sequence of operation or how you build them is different from normal patient rooms. It's up to you. We are very flexible on this level, but it will tell us how the construction sequence. Level 5 is the planning or scheduling level, which is we take it directly from Primavera or Microsoft Project or whatever tool you are using, and this is the level here. Level 6 and 7 are our addition. Level 6 is the object level. And this is something that we can easily identify and say it's done or not done. For example, foundations, columns, beams, or in the finishing stage, it's a room or one workspace area. And we build the model and identify the objects and give them names. The operations are the activities needed or what we need to do to finish that object. For example, if the activity is painting and the object is room 5, let's say it's activity is tiling and the object is room 5, the operations may be screed and tiling. So it's the work of one crew. The operation level is the work of one crew. So for this project, area location, building 1 and 2, each building was one area. And level 3 was zone level, floor plus a specified area of that floor depending on the type of construction. So the phases was structural, open space, finishing, and building, and we concentrate this time on finishing. Level 5 activity, as I said, Primavera activities. Objects are rooms in this case, and operations are all the activities within the discipline, because each activity has one tiling, painting, so all the operation needed to complete that activity in Primavera. So we decided at the beginning since we are doing a 3D model, we want to use it to measure the scope of the work. So when we build a 3D model, we also build a takeoff of all the quantities we need to build so that we finish that model. So basically, we are building, for example, a foundation. We have 3 activities we need to do: formwork, rebar, and concrete. So we calculate these quantities, and we use a standardized method of measurement, SIM7, RIC, if you are from Europe, standard. In America, it's not used a lot. But since you are working with 40 contractors, you need a standard so everybody follows it. So the model is developed based on the tender document and specification using BOQ and standardized WBS. So we have a material, full MTO is extracted, and the MTO is on the level of the object. So if we know from the takeoff from the model, each room, all the quantities all the work that you need to do to build that room. Okay? So if you want to name an object, for example, this duct, it's a project, is a KHCC, building B1, floor is floor 9, discipline is HVAC, the Primavera activity is install ducts in floor 9, and the object is duct 001, which is a sequential number. Class is duct, and then we take all the ducts and give them sequential numbering, but within this area. So the numbers will not go too big. So project WBS plus BIM tag gives you the tag number. So from BIM authoring, we come up with the object plus the quantity needs to build. We send it to our estimation system that gives us the resources, man hours we need to build this quantity. So we receive from the BIM for every object all the quantities and work to be done to complete that object, which is a room. From there, from the estimation, we find how many man hours we need, the equipment, and the material codes we need. So we send the material data directly to our material system, material procurement system. Then by taking these objects and applying them over the activity, assigning them the activities, automatically we get the time, when do we need these resources so that we can build a project on time. And by looking at the system definition, because if you notice here, we went on discipline rather than on Fragnet. And so we know what system it is, so we know the specification, and we can know what's the quality control requirement of the project. So this is a model for the floor 9, and we have defined while we're building the model that this is room, maybe room 132, this is room so and so, and this is room so and so. So automatically we can get the list of all the rooms we are going to have to manage. Plus we do virtual rooms. If we have an open space, we may subdivide it in 1 or more room numbers. So even open space we can handle. So for example, now after we build the rooms and we know the BOQ in every room, this is the amount of work we need. And from the different BOQs, we can say the room types. This is probably, these are patient room. Probably these are like the stairs and all this, and you have certain rooms like the X-ray machine room and so on. So we colorize them by different types of rooms. And here, when we click on one room, you will see all the work, all the BOQs that are available, that are needed to complete that room. And if you need later, you can see the quantities also. So basically, we have really, and then we start defining systems. This is the electrical system. This is the mechanical system. And then by intersecting with the room, we know exactly what do we need to, in every room to build. Subcontractors. Now we know what we need to build. We make a decision which disciplines we want to subcontract, most of them, and what disciplines we want to do in-house. And then we start meeting with the subcontractor, doing electronic data interface agreements, so we know what type of model we are going to receive, the takeoff we're going to receive from them, the drawings, the documents, all the procedures, the QC inspection requirements. So we agree with them on all this at the beginning before the award, so that all of them are committed to our requirements. especially the electronic data, we need to tell them when we are going to give them the, for example, the structural model so that they can load the electrical shop drawing design, the level of detail, which is the object level, naming conventions and tagging, data and document related to the object model, update frequency, when do we want them to update, and how we resolve clashes, for example. We have a procedure if we have find a clash, how we resolve it. So then from taking the objects and the BOQs that the subcontractor is responsible, we can show graphically the scope of that. I know it looks very complex, but it's very simple. Okay, and so now we have completed the subcontractor works. We know now all the activities this subcontractor needs to do to complete his section of the work. Now we come to what I call a Fragnet. A Fragnet is all the sequence of operations, how we're going to do all the work to complete a room. So basically, from the takeoff, we know the major activity, but then we have meetings on site where we coordinate with all the subcontractors and come up with a sequence of operation to build each room. See the rooms? And this is, I think, in Lean, it's called process map or something like that. But it is Fragnet per room type. We build a Fragnet per room type. How we're going, what sequence of operation? For example, you may have painting, the early painting just to make sure there's no dust in the room, and then you install other things, and then you install, at the end of the construction, you can do the last paint, and so on. So we come up for every room list of operations, disciplines within a room, and we start assigning quality control documents for handover between different disciplines and different subcontractors, so that it is two parts. We make sure that they built everything is according to our requirement, and the second, that they left the room ready for the next contractor. So basically, if he did not leave it in proper shape, we forgot some sand, we issue a punch list item, we call it type 1. Type 1 means he did not complete the work. So we are ready to start, but before we start, we have to make sure that the material and the crews are available, so we have what we call the front-end loading. Front-end loading is a document we create per work area, floor, or whatever, where we list all the material needed, the engineering needed, the drawings. If we need any equipment, like if we have a tower crane available or not, HSE requirement, especially if you have an X-ray and you want to put some special equipment, heavy equipment, we have to make sure the HSE are there. QCP is all the quality control plans that we need. Accessibility, if it's a major piece of equipment already, we have built the structure, can we make it to go through the window, or we need to open a special opening for it? Do we have enough staff, and etc. So basically, we do this list of things, and we have a front-end loading coordinator following up with everybody to make sure that all these are ready when we start construction. Some of them we have to start following up. If you notice here, this is 3 weeks, and some items needs 3 months of preparation. Okay, so especially if it's fabricated and have to be supplied by a subcontractor, so we follow up early on to make sure that it is ready when we need it. So, and then by doing the FEL and making sure everything is updated, we can see if the floor or part of the floor is ready for construction, and then we can start proceeding with the construction process. Okay, so now we are ready to start managing the construction using the 3-week look-ahead schedule. So all this information is now ready, and we can start doing the 3-week look-ahead where we take from the schedule, we take the target with for this activity, how much percent we need to be. We see because we know that this activity or schedule, what objects we need to complete them so that this activity is complete. So we select how many rooms, tiling in room 1 and 2 and 3 to complete 50% of that scheduling activities. Automatically, we can get the quantities involved. We see if there are crews available, we assign them to the crews. And we know automatically which QC forms have to be completed at the completion of these activities. And FEL makes sure that we know that everything is ready so we can proceed. And we have weekly meeting on site to validate progress and plan the next 3 weeks. So this is the screen we use, and it's a little bit not clear, but believe me, it works. And now we are changing it into this format, which is we call it the Lean Planner. This is designed to work on iPad or whatever system you are using on site, so that it will be easier. And the output from that is we get weekly by each area and by discipline who is doing what in which room. And we look at this is a byproduct of the report. We see here very easily that the electrical crew is overloaded relative to the others. So maybe if we double the number of electrical crews, everybody will be able to be more productive. We're producing also soon a line of balance to look at the productivity of crews and be able to better plan the process. So we have done the planning. Now we issue to every foreman a list of objects he has to complete, operations he has to complete for the next week. And the target % complete, and he says done, done. And this is what we call the digital pen. Anything he enters here is, once he put it in this device, all the data is transferred into our system and the progress is updated. So if this is complete, this operation probably the schedule is tiling in room so and so, and then should be 100% and he completed. This one he did not complete, and he can enter here a code if there is a problem why he couldn't complete it. So we will know by collecting these codes, we can know if there are common problems happening on the site. Okay, so basically, this is an example of another more. Basically, these are the activity ID, object ID, and the operation, fireproofing in this room, and so on. And they did 60% out of 100. And this is filled up daily. You can update this daily until the end of the week, and this data goes to the 3-week look-at meeting cycle. So basically from there we can start getting all sorts of reports. We see the progress per room. Okay, these rooms are nearly complete. Nothing is, this one is complete, and so on. And then we can go see, and this system, for example, if you have the HVAC system, you need to start it up so you can start loading equipment. You may want to make sure that all the ducts are closed so that you don't have any leakage from the HVAC system. Okay, now I can start bringing in equipment. Okay, and this was system related. So for every subcontractor, we know if he is on time or if he's late. And for every room, what's the % complete, and this is our old progress measuring. We roll up to the level of level 1 and see the total project % complete. Basically, we use man hours to weight all the activities so that we can roll up, and we got the man hours from our estimation system. Okay, so basically now at the end of the project, we want to make sure all the rooms have no punch list, and then we want to do the testing by system. So we want to make sure, if we want to test like the cold water system or the oxygen system, we want to make sure all the pipes are complete before we can start testing the system itself. So all this, we have a system called Atlas, which is also based on 3D, which is handover, QC and handover, commissioning and pre-commissioning system. So we can start documenting and doing all the dossier, handing over dossiers so that we can do all the testing before we hand over the project. So Atlas, by definition, is by system oriented rather than by location oriented. So we look at the whole system. For example, here, it looks like we can start, or this has been approved. This area is outstanding, that we need to do more, and so on. So we can plan and manage the handing over of systems and then the whole hospital. And if there is punch list, punch lists are items that are okay, the system has passed, but you want, for example, somebody have forgotten something, small something that needs it. So we create punch list and we manage it and we assign it to people who have to do this. So the handover will not be stopped. And this is the typical form that to manage the quality control and handover and punch list items. So basically, this is, for example, for subcontractor comparison sheet. This is a scope of a subcontractor with the quantities and the units. And end value is basically all the objects and operations that have been completed multiplied by their weight to get the end value of the activity and the end value of the whole project. Versus from our timesheet system, we look at the man hours actually spent and we can calculate the efficiency of every crew on site. This is, for example, end value calculation by subcontractor. This is the cost report, basically by material used and by man hours spent. We can look at and compare our budget to our cost. And all this is based on the actual progress measured using the forms I showed you before. And that's all, folks. I hope you understood what I said. I had to do it very quickly. Thank you.
Well, thank you so much, sir. We do have time for a couple of questions that I do have. I also do want to remind you that this is a great time to put in your plus deltas into the questions box, any feedback that you may have. We do want that to be sure that our webinars and other future educational offerings are exactly what you'd like to hear. So let's get down to the questions. The first one is, did the client tell you how to number spaces?
I'm not sure 100%, but no, I think if they have a room numbering, we will use it. It's easier for us. I'm not sure. In the airport in Abu Dhabi, yes, the client specified the room numbering. In this hospital, I'm not sure.
Okay, our second question is,
did you... So, sorry.
I'm sorry, go ahead.
I'm an IT guy. I don't get involved with day-to-day operations on site.
Ah, the tech guy. Gotcha. Okay. Our next question is, did you define the level of information beside the level of detail, like geometry?
Yes. When we select the BOQ we're going to use, which is within CCC, is very standard, which is used by our estimation system. So we decide what BOQ. Sometimes the client imposes it on us. If not, we will do our own. For example, you may price concrete as one item and including the rebar formwork and the concrete itself supply, or you may do them as 3 BOQs, and we usually do 3 BOQs.
Okay, our next question is, which software did you use for BIM authorizing of structures, and MEP systems?
Mostly for our work internally, we use Bentley Triforma. It's now called EcoSim, I think. Most electromechanical is done by Revit. We prefer Triforma because the formula we're used to it. It gave us at the beginning the ability to put large models together. But we follow what is happening in the market. Most electromechanical contractors prefer to use Revit.
Okay, thank you. I want to remind everybody again, please put your plus deltas and feedback into the questions box. We'd really like to hear it. Thank you so much. Our next question is...
Comment?
Oh yes, please do. I'm so sorry.
The previous, we make sure at the beginning that we can read the model from Revit or EcoSim together, so that C3D, our construction management software, can read many formats. So we bring them all together, and that's a lot of the testing we do at the beginning with the EDI, is to make sure we ask them to give us models from previous projects and make sure that they work together.
My apologies for interrupting you, sir. I am very sorry about that.
Okay.
Let's go to our next question. Did you use open BIM standards such as IFC? Do you have any interoperability issues?
Well, IFC, we use IFC. We can read IFC. The only problem I know of IFC, and I'm not really, as I told you, I'm more of although I have a construction management degree. But IFC is very too heavy on storage, and it creates a lot of records. We use IFC. If you have a drawing with IFC, we can model with IFC, we can read it.
Okay, our next question is, what is the weekly commitment to keep these documents and models up to date?
All changes come to our BIM team, and the BIM team always is updating the model so it stays current. And then it distributes. If you do the update to the structure, you send it to all contractors so that they update their models, especially if there are clashes. We have a system from Bentley to manage the request for information. We send them so that whenever we receive a new updates, we do the update to the model. Then we have what we call the scenario browser, which compares the two models and the BOQs and tell us what changed. So if there is a change in quantity, if there's a change, a column moved from one location to another, we can keep track of that so that we can then look at the impact of that change. And we notify all our subcontractors about this change.
Our next question is, what systems do you see for BIM and planning? Is this the Bentley system you were referring to?
No, we develop our own. So it is our own system. We cooperate with many, but we prefer internally to use our own system, which I think, because we are contractors, we know what we need more than they do.
Okay, our last question is, what is meant by the Fragnet level shown in the WBS?
Yeah, the Fragnet level is, you have painting, tiling. What comes first, painting or tiling? What comes first, HVAC or the Fragnet is the logic you build. You have to get it from site and from the information you receive, because the planner has done the planning early on and he does not know the specifics of what comes before something else. So the Fragnet is how we define, after we take the set of activities we have in Primavera, which is the broad Fragnet. Then we detail it using lean techniques on site, process map and all these things, to come up with the real sequence of how you build a room. And it doesn't have to be really sequential. It can be a small CPM, like 30 activity CPM, so that when you finish one operation, you want to find who can work in this room. And we're building a simulator trying to optimize this process. Thank you.
Okay, thank you. I want to remind everybody there's still a couple seconds to put in those plus deltas, so please do so. LCI would like to thank Zuhair Haddad and CCT International for putting on the webinar for us today. We also would like to thank you, our listeners, for coming to our webinar today. And we want to remind you that the recording and slide deck will be available on our Congress website at lcicongress.org within the next couple of days, so please be sure and go to that. It'll be in the exhibitor section of the website, and when you click on the CCT International logo, you'll be able to view the webinar directly. So again, thank you to everyone for joining us. CCT will be in booth 8 at our Congress this year in October 3rd through 7th. So please be sure and drop by. The booth hours are October 4th in the evening for our exhibitor sneak peek reception, the 5th from 8 to 4, and the 6th from 8 to 3. So we definitely hope to see you there. Thanks again, everybody, and we look forward to seeing you on a future webinar. Bye-bye.
Bye. Thank you.